Hi guys, I've just come out into the conservatory to do some filming because it's cool out here late at night, and I had to replace one of my bulbs. Let's just move the camera a bit. Yeah, up there I got 3 bulb strips. That gives us the main lighting in the conservatory here. Well, time 20 to 11 at night, Monday the 28th of July. Yeah, it's cooling down a little bit now. It's too hot to work in here during the day. Anyway, as I say, I've just had to change one of those bulbs because this one was flickering terribly. And I thought, well, might as well do a tear down now that we got it. Obviously, bigclivedotcom has done plenty of tear downs of these. It is a GU10 type bulb. This is the box from the one that I've just replaced, put up there. Probably from Poundland, that's where I usually buy that sort of thing. Although I did have some from another bargain store. I couldn't see any visible difference between the two of them. So they look pretty much identical. So the question is, how do we get this bit out? And is it plastic or is it glass? That sounds like plastic. So if we're lucky, we can just sort of dig around the edge and get it out. So if you want to see how it's done properly, bigclive.com. I'll put some links in the video description to some of his videos, so you don't have to search too hard. Oh, that's popped out quite easily. Okay. No doubt that will be an aluminium plate with the circuit inscribed on the top of it. If we wave that around a bit in the light, you might be able to see the copper tracks. I've no idea how they do that, but that's not really my problem. So it's copper tracks etched on top of an aluminium heatsink, in effect. Two chips, 5 LED cobs, a couple of resistors, another resistor there. Just there, that'll be the bottom end of the capacitor. One, either that one or that one. That might be the capacitor. We'll have a look in a minute when we rip it out. One will be a capacitor, the other will be the power coming in. In fact, looking at this logically, that'll be the power coming in because that track goes around to that, which I would think will be a rectifier, full bridge rectifier, to convert the AC coming in to DC. And then it'll track around there somewhere. That will be doing something. That was a good statement, wasn't it? That'll be doing something. But yeah, that'll be doing something. So that we can run 5 LEDs from it. I say 5 LEDs, there will be several LEDs on each of those. There are some numbers there. I don't know if we can read them. I don't know, is that in focus? Anyway, let's see if we can get it out. This will just be some sort of sticky goo that holds it in place. Come to think of it, I did a video not so long ago where it's one of those domed LED bulbs and showed you that if you hold the aluminium plate in a suitable heat source, it will melt all the solder for you, and they'll drop off, so you can harvest them if you want to. I mean, logically, UK runs on 240 volts AC, and when you rectify that, depending on how you rectify it, let's not get complicated. All I was going to say is each of those will have several LEDs in them, so that between them they can take the voltage. They're not going to be 3-volt LEDs that you can stick a battery on to get them running. Is that going to come out? That doesn't want to come out. I might have to cut the plastic to get them out. I can't imagine anybody isn't aware of bigclivedotcom. But he does, when he does a teardown, he reverse engineers the circuitry to tell you exactly how it works, which I certainly won't be doing. I'm just seeing if I can get it out without cutting my fingers. That does look like this has got an aluminium, well, certainly metallized surface around there, because this is plastic. It might have aluminium in there. I'm going to end up stabbing my fingers, I think, at this rate. I think the safest thing will be to cut this. I'll get a pair of cutters. Oh, just before I cut it about, GU10. GU is something to do with the actual shape or whatever. The 10 is the distance between the pins on the bottom. I say between them. It's actually the distance between the center points. So if we try and get that on there more, 9.24, I probably haven't got it just right, but yeah, that's what the 10 is. And then the actual outer diameter should be 50. That's pretty close, isn't it? 49 point something. Right, just thought I'd do that. Some people like to know what the numbers mean. Okay, see if we can get this apart. Oh yes, it has got a metallized section. That's why it wasn't popping out easily. I wonder if that... we'll find out. It still doesn't want to come out. Okay, we'll break that open. Just in case, for some misguided reason, you thought I was going to repair it. No, this is a one-way teardown. Definitely not trying to repair it. Let's get that into the bin. All right, see if we can encourage this to come apart with a bit of gentle persuasion. Oh, look at that. If we'd known we could do that from the beginning, we'd have done that from the beginning, wouldn't we? And so far I haven't actually sliced my fingers open. Some of these edges are a bit sharp, or I've been cutting them. Right, so that's our two leads going down to the pins on the bottom. One of them has clearly got a resistor in line. There we go. So that one's got a resistor on it. Big Clive would tell you why it's got a resistor on it. I won't, because I don't know. I probably did know once. I'm afraid I've forgotten an awful lot of my electrical engineering training. For those of you who wonder, I do have City and Guilds qualifications. But they are sort of 1970 something age, rather old. Things have moved on a bit since I did electrical engineering. Anyway, there's that capacitor that I was saying we would find. And that's to save them having to solder onto there. They just push it in and it's a one-way connector. Same with the power. No need to solder it. They just push them in and they clamp themselves in place. And as I say, that I think will be a rectifier bridge to convert your AC to DC to go around here. That thing I can't remember what it's for, but one would assume that we're going to be, well, obviously we're going to be powering the LEDs through that. Let's go close up a bit. You might be able to make out the track. 3 of the legs are all onto the same track. Is it 3 or is it the ones on that side as well? And that leg is the one that goes onto that track. Which sort of goes around that way and does eventually get to these. That resistor is in circuit with that LED. That track looks like it goes in that side of that LED, out of that LED, onto that one. Then that comes across to that track. Can't quite make out where it goes next, but I think it goes to that one, then to that one. And then to that one. And then round to there. Maybe. No, I'm not sure about that. Oh, if I hold that just right, you can actually see the tracks. And the date, 2009. Yeah, that'll do. You vaguely might find a use for the capacitor. So say you put it over something hot, a hot flame, and these will all just fall off when the solder melts. But there's obviously something wrong with one of them because it's flickering. So thanks for watching. Don't forget to like and subscribe. Leave us a comment so I know how I'm doing. And somewhere up here there'll be some links to related playlists. Thanks again.